this is Kasturi De. Now I'm going to discuss the last portion of the language of chemistry chapter. It's a chemistry chapter according to ICSE syllabus class 8. Okay. So in my last video I discussed about how to balance the chemical equation and how it is can be made informative. Okay. So what are the information we can get from the this chemical equation, and what are the limitations of this chemical information? Okay, so in my this balanced chemical equation shows what are the reactants, what are the products, the number of molecules of the reactants, the number of molecules of the products, and the relative atomic mass of the reactants, and the number the relative atomic mass of the products. Okay. Now the limitations, like we are not able to know the physical state of the reactants and the products. Okay, the concentration of the reactants and the products, the time taken to complete the reaction, the rate at which it is the reaction is proceeding, the heat changes, okay, whether the heat is given out or absorbed, the temperature, whether it is what temperature in which it is acting, the catalyst, the pressure, okay, the nature of the reaction, whether it is reversible or irreversible. So these are the limitations of the chemical equation. Now to make them more informative, we need to add all these. Okay, so how will you add it? First is the physical state of the reactants, like whether it is a solid or a liquid or gas, okay, or it is an aqueous solution. We write these things by mentioning, like see, mentioning S, okay, as for solids, beside the name of the element, beside the symbol of the element or the compound, whether it is a solid for S, then liquid L for liquid, then G for gas, aqueous AQ for aqueous state. Okay, now evaluation or absorption of heat during the reaction can be denoted by adding or subtracting a heat term on the product side. Okay, on the product side, whether the heat is absorbed or it is evolved, okay, it is evolved, that can be mentioned by using plus heat, that is it is absorbing heat, or it is subtracting a heat term on the product side, whether it is giving out heat, that is plus heat, whether it is giving out heat, or whether it is absorbing heat, that it is minus, that is subtracting heat from on the product side. Now the temperature, pressure, and catalyst, that can also be mentioned, indicated above the arrow sign which is separating the reactants and the products. If it is a catalyst, what is the temperature, like say it is requiring 100 degrees centigrade of temperature, 5 atmospheric pressure it is required. Catalyst, say iron catalyst or molybdenum catalyst, a promoter is required. All these are written above the arrow and the separating the reactants and the products. Okay, I want to tell you one thing, all these things should be written above the arrow. Okay, I have written in my all these equations which I have written here in the slides, I've written it downwards because I'm not able to write it above. Okay, so please forgive me for that, but you should write them above the arrow. Okay, this facility is not available in my slide which I am doing, so that's why I've written it downwards, but you should write it above the arrows. Okay, now concentration of the reactants and products are indicated by adding the words dilute or conc, or DIL or conc for concentrated. Okay, if the reactants are dilute or concentrated, then by the sign of this one, single arrow or double arrow information is reversible or irreversible. If it is irreversible, single arrow, reversible, then it is double arrowed. Reaction is depicted between where there is the arrow which is there between the reactants and the products. Then upward arrow, okay, indicates the gas is evolved. Downward arrow indicates the precipitate or insoluble solid that is formed. Okay, then delta sign, okay, this triangular sign is known as delta sign, that indicates the heat which is evolved or absorbed. Okay, plus heat, that means evolved, minus heat, that means absorbed. Next is the C, plus sign, I told you, minus sign, the heat is absorbed. Then see, the example is there, nitrogen plus hydrogen gives us ammonia. This is a reversible reaction. Okay, here this catalyst used are Fe catalyst, and with the promoter molybdenum is used. Temperature required is 400 to 450 degrees centigrade, and atmospheric pressure is 200 to 900 degree 900 atmospheres. Nitrogen is a gas, hydrogen is also a gas, and ammonia is also a gas, and heat is evolved in this reaction. Now from the above equation, it is said that the reactants nitrogen and hydrogen is and the product ammonia are gases. The reaction is reversible reaction and exothermic, because heat is plus heat on the product side. Then the reaction took place at a temperature of 400 to 500 degrees centigrade at a high pressure between 200 to 900 atmospheres. The catalyst, a substance which, catalyst, what is a catalyst? It is a substance that do not take part in the chemical reaction, but it changes the rate of the reaction. That is, here it is used as iron, and molybdenum acts as a promoter. What is a promoter? It increases the efficiency of the catalyst. Okay, the catalyst, it increases the rate, increases or decreases the rate of the reaction, and that efficiency is increased by the promoter. Okay, so for example, see, sodium chloride and silver nitrate aqueous solution that gives silver chloride as a precipitate and sodium nitrate as aqueous solution. Okay, so this is the end of the chapter. Please go through this. If you have any doubt, please do write in the comment box. Please do like and share with your friends so that they can also be benefited from this. And please do subscribe to get the notification of my next video. And in my next video, I'll be discussing this question answers of this chapter. And also I'll start with another chapter of chemistry. Okay, so thank you for watching and have a good day.